Let me tell you about the day a checkers game changed the Pacific Air War. June 26, 1944, Hollandia Air Base, New Guinea. Lieutenant Colonel Charles MacDonald was concentrating on his next move when someone knocked at the screen door of the recreation hut. The civilian standing there introduced himself once. MacDonald barely heard him. He was focused on the board. So the man said it again, quietly but clearly. Charles Lindbergh. MacDonald's head snapped up. That Charles Lindbergh? The man who flew to Paris? The most famous pilot in America was standing in the doorway of a dirt floor fighter squadron in the middle of nowhere, asking to talk about fuel efficiency? Neither man could have known it then, but that interruption would extend the P-38's combat range by 400 miles, rewrite operational doctrine, and prove that the greatest breakthroughs sometimes come not from new technology, but from finally understanding the technology you already have. MacDonald invited him in, more out of courtesy than curiosity. Lindbergh was polite, almost deferential. He wanted to observe P-38 operations, he said. Maybe fly a few missions, if that was acceptable. He was particularly interested in fuel consumption patterns during long-range combat sorties. Lieutenant Colonel Merrill Smith, the operations officer sitting across the checkers board, exchanged a glance with MacDonald. Another consultant. They'd seen plenty of those. Engineers from Lockheed, technical representatives from Wright Aeronautical, even a fuel chemist from Standard Oil. All of them arrived with theories. None of them had flown combat. Lindbergh seemed different, though, quieter. He asked questions instead of offering answers. What were the typical fuel loads for escort missions? How much reserve did pilots feel comfortable with over enemy territory? Had anyone experimented with leaner mixture settings at altitude? Before we continue, click that subscribe button, like this video, and let me know in the comments where you're watching from. It brings me great joy knowing that these war stories and lessons get to people all over the world. Your support helps us bring more thrilling war stories, and trust me, you won't want to miss them. Now, let's get back to the story. The questions were specific, technical, not the kind a celebrity would ask for publicity purposes. Still, there was skepticism in the room, unspoken but present. These men flew P-38s into combat nearly every day. They knew their aircraft. They knew what the engines could handle and what would get you killed. They'd lost friends to fuel starvation, to engines that quit over the jungle because someone pushed the range too far. And now, this civilian, famous or not, wanted to talk about flying farther. MacDonald was diplomatic. "We're always interested in extending range, yes," he said carefully, "but we're also interested in getting our pilots home alive." Lindbergh nodded. "Of course. I wouldn't suggest anything I wasn't willing to test myself." That got Smith's attention. "You planning to fly missions with us?" "If you'll have me," Lindbergh said simply. "I've been checked out in the P-38. I'd like to fly combat operations, see how the aircraft performs under actual conditions." There was a pause. MacDonald studied the man in front of him. Lindbergh was 42 years old, older than most of the pilots in the squadron. He was a civilian in a combat zone. He had no rank, no authority, no official standing. But he wanted to fly. "We'll see," MacDonald said finally. "Let me talk to General Wurtsmith." Lindbergh thanked him and left as quietly as he'd arrived. Smith looked at MacDonald across the abandoned checkers game. "What do you think?" MacDonald shrugged. "I think we're about to find out if fame means anything at 20,000 feet." The path to that screen door in Hollandia began 17 years earlier, over the Atlantic Ocean. On May 20th, 1927, Charles Augustus Lindbergh had transformed aviation forever by flying 30,600 miles from New York to Paris alone in 33.5 hours. The Ryan NYP monoplane he flew, Spirit of St. Louis, carried 450 gallons of fuel in tanks so large they blocked his forward vision. Lindbergh navigated by periscope and dead reckoning, managing fuel consumption with a precision that would have seemed paranoid to other pilots of that era. He landed at Le Bourget Field with 85 gallons remaining. That wasn't luck. That was mathematics. The world saw a daring young aviator who conquered the Atlantic. What they didn't see was the obsessive fuel management that made it possible. Lindbergh had calculated every variable: engine RPM, manifold pressure, mixture settings, altitude, temperature, wind drift. He'd found the exact operating envelope where his right whirlwind radial engine delivered maximum range without sacrificing reliability. That meticulous attention to fuel efficiency became Lindbergh's defining technical expertise. Throughout the 1930s, he conducted survey flights for Pan American Airways across the Pacific and Atlantic, pioneering routes that would become commercial air corridors. On those flights, often covering thousands of miles over open ocean, Lindbergh refined techniques that extended aircraft range far beyond manufacturer specifications. He understood something most pilots didn't. Published range figures were averages, not limits. Every engine had an optimal operating envelope, where power output, fuel consumption, and mechanical stress reached perfect balance. Finding that envelope required understanding the relationship between manifold pressure, propeller RPM, and mixture settings in ways that went far beyond standard training. By 1944, Lindbergh had become one of the world's foremost experts on long-range flight. But his relationship with the United States military was complicated. In the years before Pearl Harbor, Lindbergh had argued passionately against American involvement in European conflicts. He'd led the America First Committee, delivering speeches that earned him both national support and powerful enemies. President Franklin Roosevelt publicly compared him to Civil War traitors. On April 28, 1941, Lindbergh resigned his Army Air Corps Reserve Commission in protest. When Pearl Harbor forced America into war, Lindbergh tried to rejoin. Roosevelt personally ensured he would never wear an American military uniform again. But expertise finds a way. Unable to serve as a military officer, Lindbergh became a civilian technical consultant for aircraft manufacturers. He joined United Aircraft Corporation in 1943, working with their Chance Vought division on the F-4U Corsair. He spent time at Ford's Willow Run plant troubleshooting B-24 production problems. He flew dangerous high-altitude test flights in P-47 Thunderbolts, analyzing engine performance under combat conditions. His contributions were significant, but Lindbergh wanted more than lab work. He wanted combat. By early 1944, he'd found his opening. United Aircraft needed data on twin-engine fighter performance, and the only American twin-engine fighter seeing heavy combat was the Lockheed P-38 Lightning. Lindbergh convinced them to send him to the Pacific as a technical observer. The trip was authorized by the Navy Department, but kept secret from the White House. On June 26, 1944, that authorization brought him to a dirt-floor recreation hut in Dutch New Guinea, standing in front of combat pilots who had no idea what he knew or what he was about to teach them. Lindbergh flew his first mission with the 475th Fighter Group on June 28th, 2 days after the Checkers game. It was a routine sweep, 8 P-38s escorting bombers to a Japanese supply depot near Manokwari. Lindbergh flew as wingman to Captain Lowell Smith, staying in formation, saying little over the radio. The mission lasted 4 hours and 17 minutes. No enemy contact, no drama. But when the formation landed back at Hollandia, something unusual happened. The crew chief assigned to Lindbergh's aircraft stood staring at the fuel gauges, then rechecked them, then called over another mechanic. They compared notes, looked at the mission log, and checked the gauges again. Lindbergh's P-38 had returned with significantly more fuel than any other aircraft in the formation. Not a little more, a lot more. The crew chief approached Lindbergh as he climbed down from the cockpit. "Sir, did you have any fuel system malfunctions? Gauges acting strange?" Lindbergh shook his head. "Everything normal. Why?" "You've got nearly 40 gallons more than Lieutenant Morrison, and he was flying right next to you the whole time." Lindbergh smiled slightly. "Different cruise settings." The crew chief didn't know what to make of that, so he noted it in the maintenance log and moved on. But word spread through the ground crews. The civilian was doing something different with his engines, and whatever it was working. Over the next 2 weeks, Lindbergh flew 8 more missions: bomber escorts, fighter sweeps, armed reconnaissance. Each time, he returned with fuel reserves that shouldn't have been possible, given the mission duration and distance. The pilots started noticing. After one particularly long mission to Noem Island, over 600 miles round trip, Lieutenant Perry Dahl landed with his fuel warning light flickering. Standard procedure. Everyone pushed the P-38's range on those runs, but Lindbergh climbed out of his cockpit with fuel to spare. Dahl approached him in the debriefing tent. "How are you doing that?" "Doing what, sir?" Lindbergh asked. "Coming back with gas in the tanks. We flew the same mission, same formation, but I landed on fumes and you look like you could fly another hour." Lindbergh considered his answer carefully. "I'm running leaner cruise settings than standard, different manifold pressure and RPM combinations." Dahl frowned. "You mean over-square settings?" "In some phases, yes. That'll blow your engines." "It hasn't yet," Lindbergh said quietly. The conversation ended there, but it didn't stop. Other pilots began asking questions. How much leaner? What manifold pressure exactly? What about cylinder head temperatures? Weren't the manuals clear about maximum continuous power settings? Lindbergh answered patiently, technically, but he could see the skepticism. These men had been trained by the Army Air Forces. They'd been taught specific procedures for engine management, procedures designed to prevent catastrophic failures at altitude over enemy territory. And now a civilian was suggesting those procedures were wrong? MacDonald watched the growing tension with interest. His pilots were curious, but they were also cautious. Aviation didn't reward experimentation. It rewarded survival. The question hanging over Hollandia wasn't whether Lindbergh's techniques worked for him. It was whether they'd work for anyone else or get someone killed trying. The meeting happened on July 10th, in the operations tent at Hollandia. MacDonald had assembled his squadron commanders and senior pilots. Lindbergh stood at the front near a chalkboard, looking more like a visiting professor than the world's most famous aviator. He'd been flying missions with the group for 2 weeks. Now MacDonald wanted to hear what he had to say. Lindbergh got straight to the point. "You're flying your engines too rich and too fast," he said. It's costing you 30 to 40% of your potential range." The room went quiet. Captain Lowell Smith spoke first. "The tech orders are pretty specific about cruise settings. Manifold pressure below RPM, always. That's not a suggestion. That's engine preservation." Lindbergh nodded. "I've read the same manuals, but the manuals are conservative. They're written for the worst pilot under the worst conditions. You can do better." "Better how?" Lieutenant Perry Dahl asked. Lindbergh turned to the chalkboard and wrote 2,200 RPM, 31 inches manifold pressure. "That's over square," someone said from the back. "That's exactly what they tell us not to do." "It is over square," Lindbergh agreed. "And at cruise altitude with proper mixture leaning, it's also the most efficient power setting the Allison V1710 can produce. You get adequate thrust, lower fuel consumption, and, critically, lower cylinder head temperatures than you're running now." Major Thomas McGuire leaned forward. McGuire was already a 21-kill ace, one of the most aggressive pilots in the theater. "Lower temperatures? That doesn't make sense. Higher manifold pressure means more combustion pressure. More pressure means more heat." "Under full power, yes," Lindbergh said. "But at cruise settings, you're running leaner mixture. Less fuel means less heat. The math works." "The math," Smith said slowly, "says we'll get engine detonation, pre-ignition, cracked cylinders, and when that happens at 20,000 feet over Japanese-held territory, the math won't matter because we'll be dead." The tension in the tent sharpened. These men had seen friends die from engine failures. P-38s lost over the jungle because one Allison quit and the aircraft couldn't maintain altitude on a single engine. Fuel starvation was one thing. You could glide, maybe find a beach. Catastrophic engine failure was something else entirely. Lindbergh met Smith's eyes. "I understand the concern. I've been flying these settings for 2 weeks. 9 combat missions, 0 engine problems. Temperatures stay within limits. No detonation, no unusual vibration." "You've been lucky," Dahl said. "Maybe," Lindbergh acknowledged. "Or maybe the engines are capable of more than we've been taught." MacDonald had been silent, listening. Now he spoke. "What you're suggesting goes against every bit of training these pilots have received. You're asking them to ignore institutional knowledge, to trust your experience over Army Air Force's doctrine." Lindbergh didn't flinch. "I'm asking them to test it. Fly one mission my way, monitor your temps, check your fuel consumption. If it doesn't work, go back to standard settings. But if it does work—" He didn't finish the sentence. He didn't need to. If it worked, everything changed. The room stayed silent. Outside, P-38 engines fired up for the afternoon patrol. Inside, men wrestled with a choice between safety and possibility. If you enjoy dramatic, jaw-dropping stories, subscribe to WW2 Archives Declassified. Let's grow this channel to 1,000 subscribers. The first volunteer was Perry Dahl. Not because he believed Lindbergh was right, but because he wanted to prove him wrong under controlled conditions where failure wouldn't mean death over the jungle. "I'll try it on a local flight," Dahl told MacDonald after the meeting. "Stay within gliding distance of the base. If the temps spike, I'll know immediately." MacDonald approved. "Better to test it now than have someone experiment during combat." On July 12th, Dahl took off alone in a P-38J, climbed to 20,000 feet, and carefully adjusted his settings to what Lindbergh had written on the chalkboard. 2 to 200 RPM, 31 inches manifold pressure, Mixture leaned until the engine ran smooth. For the first 10 minutes, he watched his cylinder head temperature gauges like they were enemy aircraft. The needles stayed steady. Normal range, no climbing, no fluctuation. He flew for an hour, monitoring everything: oil pressure, coolant temperature, manifold pressure, RPM. The engines ran smooth. Smoother than usual, actually. Less vibration at the lower RPM setting. When Dahl landed, his crew chief was waiting with the fuel readings. "You used 30 gallons less than your last flight of the same duration," the crew chief said, checking his calculations twice. "Maybe more. These gauges aren't exact, but—" Dahl didn't wait for him to finish. He walked straight to the operations tent and found Lindbergh reviewing maps with McGuire. "It works," Dahl said simply. Word spread fast. Within 3 days, a dozen pilots had run test flights. Same results every time: fuel consumption down, temperatures normal, engines running smoothly. Lieutenant Bob Wood extended a routine patrol by 45 minutes without touching reserve fuel. Captain Danny Roberts flew a reconnaissance mission that would normally require drop tanks, and did it on internal fuel alone. The evidence was becoming impossible to ignore. On July 15th, MacDonald authorized Lindbergh to brief the entire group. This time, the meeting had a different energy. The pilots weren't skeptical anymore. They were hungry for details. Lindbergh walked them through the complete technique: cruise climb at higher manifold pressure, level flight at 2,200 RPM, aggressive mixture leaning at altitude, constant monitoring of cylinder head temps. The methods weren't complicated, but they required attention and trust in the gauges. "You'll feel like you're over-temping the engines," Lindbergh said. "You're not. You're running them efficiently for the first time." The questions came faster now. Practical questions. What about combat power? Could they still push the engines hard when needed? Yes. What if they had to change altitude quickly? Adjust mixture accordingly. What about different atmospheric conditions? Monitor temps and lean as needed. McGuire asked the question everyone was thinking: how much farther can we actually fly? Lindbergh pulled out a map and marked distances. Missions you're scrubbing because of fuel concerns? Most of them become possible. Targets you're barely reaching? You'll have combat time over them instead of turning for home immediately. Your effective combat radius increases by at least 100 miles, maybe more. The room went quiet again, but this time it wasn't tension. It was possibility. They weren't just saving fuel anymore. They were rewriting the air war's geometry. July 28, 1944. The mission brief was straightforward. Fighter sweep over the Saram airfield complex, hunting for Japanese fighters protecting their supply line to the southern Philippines. Lindbergh flew as wingman in a flight of 4 P-38s, led by Lieutenant Colonel Merrill Smith. Intelligence expected resistance. They got it. 20 minutes from the target, Smith's voice cracked over the radio. "Bogies, 11 o'clock high." 4. "No, 5 aircraft. Look like Oscars." They weren't Oscars. They were Mitsubishi A6M0s, lighter, more maneuverable, and flown by pilots who'd been fighting this war since 1941. The engagement happened fast. Smith's flight dove on the Japanese formation. The Zeros scattered, then regrouped, turning into the attack with the vicious agility that had made them legendary. What should have been a quick bounce turned into a swirling dogfight at 15,000 feet. Lindbergh stayed on Smith's wing through the first pass, then lost him in a hard climbing turn. He found himself alone, a Zero sliding into firing position 400 yards behind him. Lindbergh pushed the throttles forward, combat power, manifold pressure redlined, and dove. The P-38 accelerated like physics had been suspended. 8,000 feet in seconds. The Zero followed, but couldn't match the dive speed. Lindbergh pulled out hard at 5,000 feet, the airframe groaning, and reversed back toward the fight. That's when he saw it. A Zero crossing left to right, 200 yards ahead. Pilot focused on a damaged P-38 trailing smoke. Lindbergh didn't think. He pulled lead, thumbed the gun trigger, and Owen watched his .50 caliber tracers converge on the Zero's engine cowling. The Japanese fighter shuddered. Smoke poured from the engine. The Zero rolled inverted and fell away, trailing fire. Lindbergh's first kill. He didn't have time to process it. Another Zero materialized behind him. Close, maybe 150 yards, already firing. Tracers snapped past his canopy. Lindbergh broke hard right, then reversed left, trying to shake the pursuit. The Zero stayed with him, closer now. Lindbergh could see the pilot's face. His altitude was bleeding off. 3,000 feet, 2,500. The jungle canopy filled his windscreen. He firewalled the throttles, dumped the nose, and ran. Full power, everything the Allisons could give. The P-38 clawed for speed at treetop level, 280 knots, 300, 320. The Zero hung on for a few more seconds, then fell behind. It couldn't match the lightning speed in level flight. Lindbergh climbed back to altitude, hands shaking, and rejoined the formation for the flight home. When they landed at Hollandia, Smith was waiting on the tarmac. He'd seen the whole thing. "Clean kill," Smith said, extending his hand. "And good flying on that escape. Thought he had you." "He almost did," Lindbergh admitted. By evening, the story had spread through the entire group. The civilian consultant had splashed a Zero and survived a point-blank pursuit by another. He'd flown combat, real combat, and proven himself under fire. The skepticism evaporated. Lindbergh wasn't a theorist anymore. He wasn't a celebrity visiting the war. He was a fighter pilot who'd earned his place in the formation. By mid-August 1944, the change was spreading beyond the 475th Fighter Group. What had started as a controversial experiment in fuel management had become standard operating procedure. Pilots across 5th Air Force P-38 squadrons were adopting Lindbergh's techniques, cautiously at first, then with growing confidence as the results became undeniable. The numbers told the story. Missions that had previously required external drop tanks could now be flown on internal fuel alone. Fighter sweeps that once ended at 400 miles could push to 550, even 600 miles. The P-38's effective combat radius, the distance at which pilots could fight and still return home, had increased by more than 30%. Targets that had been out of reach were suddenly vulnerable. In late August, the 475th flew escort for B-24 bombers striking Japanese positions in the Halmahera Islands, a mission previously considered impossible without forward staging bases. The P-38s arrived over target with enough fuel for 20 minutes of combat maneuvering, engaged Japanese interceptors, and returned to base with comfortable reserves. Zero aircraft lost to fuel exhaustion. General George Kenney, commander of 5th Air Force, took notice. He ordered Lindbergh's techniques documented and distributed throughout the theater. Flight schools updated their curriculum. Technical orders were revised. What the Army Air Forces had taught as gospel for 3 years was quietly rewritten. the strategic implications rippled outward. General Douglas MacArthur's island-hopping campaign toward the Philippines depended on air superiority, and air superiority depended on range. Every additional 100 miles the P-38s could fly meant one fewer base to capture, one fewer amphibious assault to mount, one fewer month added to the timetable. Lindbergh's fuel efficiency didn't just save gasoline. It saved time. It saved lives. Fighter escorts could now protect bombers deeper into Japanese-held territory. Reconnaissance missions could probe farther, giving intelligence officers better targeting data. Combat air patrols could stay on station longer, providing continuous coverage over invasion beaches. The operational flexibility fundamentally changed how 5th Air Force planned missions. By September, the 475th Fighter Group alone had flown more than 200 extended-range missions using Lindbergh's methods. Aircraft that would have been grounded for fuel concerns were flying. Pilots who would have nursed fuel gauges all the way home were fighting with confidence. MacDonald summarized it in a report to General Kenny. "The techniques introduced by Mr. Lindbergh have increased our effective striking power by approximately 1/3 without any corresponding increase in our aircraft losses or mechanical failures. We are now operating routinely at ranges we previously considered emergency maximums." Other groups reported similar results. The 8th Fighter Group, the 49th, the 348th. Across the Pacific Theater, P-38 squadrons were pushing deeper into Japanese airspace, staying longer, fighting harder. The transformation wasn't just tactical, it was cultural. Pilots learned that published specifications were starting points, not boundaries. That institutional knowledge could be improved. That sometimes the greatest innovations came not from new technology, but from understanding existing technology more deeply than anyone thought possible. A civilian with no rank and no authority had changed how America fought the air war, not through orders or regulations, through mathematics, evidence, and the courage to challenge what everyone believed was already known. Charles Lindbergh left the Pacific Theater on September 12, 1944, as quietly as he had arrived. No ceremony, no formal recognition. He simply packed his gear, said goodbye to the pilots he'd flown with, and caught a transport back to the United States. The Army Air Forces never officially acknowledged his contributions. His combat missions remained technically unauthorized. His aerial victory was never added to any official tally. But the men who flew with him knew. In the months that followed, the techniques Lindbergh taught became foundational to P-38 operations throughout the Pacific. Flight training manuals were rewritten. Engine management procedures were updated. What had been considered heresy in July became standard practice by October. The impact extended beyond fuel efficiency. Lindbergh had demonstrated something more valuable than a specific RPM setting or manifold pressure number. He'd proven that expertise earned through experience could challenge institutional doctrine and win. That careful observation and rigorous testing could reveal capabilities hidden in plain sight. That the courage to question accepted wisdom was sometimes the most important skill a pilot could have. Lieutenant Colonel MacDonald would later write, "Lindbergh taught us that the limitations we accepted weren't always real. They were often just the boundaries of what we'd been willing to test." The redemption Lindbergh sought, barred from uniform, exiled from military service, came not through politics or public relations, but through competence demonstrated under fire. The pilots of the 475th Fighter Group didn't care about his pre-war speeches or his conflicts with Roosevelt. They cared that he'd flown combat missions, survived a zero on his tail, and given them tools that brought them home alive. In a war defined by industrial output and technological superiority, Lindbergh's contribution was different. He didn't design a new aircraft or invent revolutionary technology. He simply understood existing systems more deeply than the engineers who built them. Knowledge as a force multiplier. By war's end, the extended-range capabilities Lindbergh pioneered had become so routine that pilots barely remembered flying any other way. The impossible had become standard procedure, just as he'd promised that day in the operations tent at Hollandia. The P-38 Lightning would go on to become one of the most successful fighters of the Pacific War, not because its design changed, but because pilots finally learned how to use it correctly. And that lesson extended beyond aviation. In any complex system, mechanical, organizational, human, true capability often exceeds documented limits. The difference between specification and reality is understanding. The gap between impossible and routine is knowledge applied with precision and courage. Lindbergh proved that in 6 weeks over Dutch New Guinea. A checkers game interrupted, a civilian asking uncomfortable questions, and hundreds of pilots flying home with fuel to spare because one man refused to accept that what everyone knew was all there was to know. That's the story, not of technology, but of what happens when expertise meets humility, when evidence overcomes tradition, and when the courage to question transforms the impossible into something far more powerful, the everyday routine of men who now knew better. Don't just watch, subscribe. Help Archives. Declassified hit 1,000 subscribers.